Welcome, dear viewers, to the Wow Info YouTube channel, your one-stop destination for unraveling the mysteries of the universe, right from the comfort of your home. Today, we're embarking on a whirlwind tour, a cosmic journey if you will, and we're thrilled to have you on board. Our topic of exploration, the Earth's rotation, and the intriguing question of why we don't feel it. As you go about your day, have you ever stopped to think about the fact that you're on a planet that's spinning on its axis at a speed of 1,040 miles per hour? Boggles the mind, doesn't it? Yet, despite this dizzying speed, we feel as if we're standing perfectly still. How is this possible? What's the science behind this phenomenon? Over the next few scenes, we'll dive deep into this fascinating topic, exploring the concepts of Earth's rotation, inertia, gravity, and our own sensory perception. We'll unravel the reasons why we don't feel the Earth's rotation and understand the grand cosmic dance that we're all a part of. So, sit back, relax, and prepare to have your mind blown as we embark on this epic journey of discovery. Let's dive in. Picture this. You're standing still, feet firmly on the ground, feeling the wind on your face and the sun on your skin. Everything around you seems stable and unmoving. But what if we told you that you're actually spinning, twirling, and pirouetting at a dizzying speed? And no, we're not talking about a dance routine. We're talking about the grand cosmic dance that you and everything else on Earth are a part of every single day. You see, our planet, the Earth, is like a massive spinning top, constantly rotating on an invisible axis. This rotation is what brings about the cycle of day and night, the rising and setting of the sun, and the changing of the seasons. Yet despite this ceaseless movement, we don't feel like we're spinning at all. Why is this so? How can we be moving and yet feel like we're perfectly still? The answer to this intriguing question lies in the interplay of several scientific principles: the Earth's rotation, inertia, gravity, and our own sensory perception. In the following scenes, we will be unraveling this fascinating mystery, delving into the science behind the Earth's rotation, our movement with it, and how our senses perceive this motion. So buckle up as we embark on this cosmic journey, exploring the dance between our planet, physics, and our perception. Imagine a spinning top gracefully twirling on a table. Now, replace that top with a giant blue and green sphere. That's our Earth, spinning on its invisible axis. As we zoom in, we see the Earth not as a still image, but as a dynamic spinning globe. The Earth rotates on its axis, an imaginary line running from the North Pole to the South Pole. This rotation is constant, smooth, and unending, much like the spin of our metaphorical top. The Earth doesn't slow down, speed up, or wobble in its rotation. It just keeps spinning, hour after hour, day after day, year after year. This ceaseless rotation is what gives us our days and nights. As the Earth spins, different parts of the world face towards or away from the sun, resulting in the cycle of day and night that we experience. So the next time you watch a sunrise or a sunset, remember this. You're not just witnessing a beautiful spectacle of nature, you're seeing the effects of our Earth's constant, graceful spin, a cosmic dance that's been going on for billions of years. This dance is not just something we observe, but something we're a part of, a dance we're all in together. Visualize this. You're on a train, comfortably seated, watching the world whiz by through the window. Despite moving at a considerable speed, you don't feel like you're moving at all. This is because everything around you, the seats, the passengers, the coffee in your cup, is moving with the same speed and direction as you are. This makes the train's motion imperceptible until it starts to speed up, slow down, or change direction. Now, let's take this concept and expand it to a cosmic scale. The Earth, this massive celestial body we call home, is constantly moving, spinning around its axis. This motion is a lot like our train ride, but on a much larger scale. Just as you don't feel the movement of the train, you don't feel the Earth's rotation. This is because everything around us, trees, buildings, the air, the people, are all moving with us at the same speed and direction. Our planet's rotation is a large-scale and constant motion, much like being on a moving train. We don't feel this motion because there are no sudden accelerations or decelerations, no abrupt turns or stops. The Earth's rotation is smooth and constant, making it almost impossible for us to feel it. So the next time you gaze up at the starry sky or enjoy a beautiful sunset, remember that you're not just standing still. You're riding along on a spinning planet, moving at a tremendous speed, and you don't even feel it. This is the magic of our cosmic carousel, a dance of physics that we're all a part of, whether we realize it or not. Imagine yourself aboard a high-speed train. As it begins its journey, you feel the initial acceleration, but once it reaches a constant speed, you're able to move around the cabin, sip your coffee, and even take a nap. It's as if you're not moving at all. This is similar to the Earth's rotation. Just as the train moves along its tracks, the Earth moves along its orbit, spinning about its axis. Both are in constant motion, yet we don't feel it. The train's interior, seats, tables, and even your cup of coffee moves at the same constant speed as you do. Similarly, on Earth, the trees, buildings, and everything around us is moving at the same constant speed as we are. In both scenarios, the movement becomes noticeable only when there's a change in speed or direction. If the train suddenly speeds up, slows down, or takes a sharp turn, you'll feel it. Likewise, if the Earth's rotation were to change dramatically, we'd feel that too. But since our planet's rotation is smooth and consistent, we don't feel it. Just like we don't feel the motion of a train moving at a constant speed. So the next time you're on a train, remember this analogy. Just as you don't feel the motion of the train when it's moving at a constant speed, you don't feel the Earth's rotation. It's a fascinating comparison that helps us understand our place in the cosmic dance. Have you ever sat on a spinning playground carousel and marveled at the world whirling around you? Now, magnify that experience to planetary proportions. Today, we delve into a thought-provoking question. Despite the Earth's constant rotation, why do we feel stationary? Let's unlock this intriguing enigma using the keys of scientific inquiry and human fascination. The Earth, the celestial sphere we call home, is never still, but we aren't tossed about like clothes in a dryer each day. To decode this, we need to explore the principles of physics at work here. The Earth is an immense cosmic entity, spinning around an unseen line called its axis. The North Pole and the South Pole mark the ends of this axis, the fulcrum, about which the Earth rotates. This revolving motion, known as the Earth's rotation, is a cornerstone of planetary physics. The Earth completes one full rotation approximately every 24 hours. Visualize a colossal clock where the Earth serves as the hour hand. Each day, our planet executes one full rotation, ushering in the cycle of day and night. This rotation brings forth the sunrise in the east and sunset in the west, painting our familiar canvas of light and darkness. As the Earth pirouettes, everything on it, including us, is twirling at an identical speed. Evident when we're on a moving train or car, where we're traveling at the same speed as the vehicle but can still navigate within it. This is due to inertia, the inherent propensity of objects to stay in motion. This principle, first highlighted by Sir Isaac Newton, underpins physics and is applicable here. Our inertia is our motion in harmony with the Earth's rotation. We are part of the Earth's rotational ballet, moving to the same rhythm and tempo. Consequently, we don't feel the spin since we are in the dance itself. Let's discuss gravity next. An unseen force, gravity is as old as time, yet we rarely appreciate its presence. It keeps us anchored to the Earth's surface, oblivious to the planet's unremitting rotation. Simply put, gravity is the force that draws us towards Earth's core. It prevents us from hurtling into the cosmos as the Earth spins. In the absence of gravity, the Earth's rotation would scatter everything not secured to the ground into space. But gravity ensures we stay put. It continuously pulls us and everything else towards the Earth's center, making us feel as if we are stationary relative to the Earth's surface. Lastly, let's delve into the role our bodies and senses play in this cosmic dance. Over millions of years of evolution, our bodies and senses have fine-tuned themselves to the Earth's rotation. For instance, our sense of equilibrium, moderated by the inner ear, is accustomed to Earth's gravitational pull and rotation. We don't have sensory organs that can directly detect the Earth's rotation because our physiology has evolved to be in sync with our environment. Our perception of motion, or the lack thereof, hinges on the sensory data our bodies gather and process. In the absence of external stimuli or feelings of acceleration, our brains perceive us as being stationary. We think of ourselves as immobile because, without sensory inputs, our bodies and brains find no reason to think otherwise. In conclusion, the reason we don't feel the Earth's rotation lies in the symbiotic dance of the Earth's spin, gravity, our inertia, and sensory perception. This beautifully choreographed interplay in the absence of external stimuli or sensations of acceleration makes us perceive ourselves as stationary, even though we are part of the Earth's majestic pirouette. Have you ever wondered about the invisible tether that keeps us grounded, even as our planet spins on its axis? Welcome to the world of gravity. This unseen force is integral to our everyday life, yet we seldom appreciate its impact. Imagine standing on a spinning top without a force to hold you in place. You'd be flung outwards, right? Now picture the Earth as that spinning top. It's rotating at an incredible speed, yet we're not sent hurtling into space. The reason? Gravity. As we speak, gravity is at work, pulling everything towards the Earth's center. This constant force is what keeps us anchored to the Earth's surface, oblivious to its relentless rotation. With the help of a visual, let's delve deeper into this concept. Gravity is an ever-present force, pulling us and everything else toward the center of the Earth. It's like an invisible string, constantly tugging at us, keeping us rooted to the ground. This force makes us feel stationary, even though we're on a spinning planet. Without gravity, we'd be like feathers in the wind, tossed about by the Earth's rotation. But thanks to this unseen force, we stay put, feeling as though we're not moving at all. So the next time you're standing still, remember that you're not actually stationary. You're spinning along with the Earth, kept in place by the incredible force of gravity. It's a sobering thought, isn't it? Thanks to gravity, we don't feel like we're spinning out of control. We're part of a cosmic dance, moving in sync with our planet, yet feeling perfectly still. It's truly one of the universe's most fascinating paradoxes. Our perception of motion depends on our frame of reference. This concept, rooted in physics, is essential to understanding how we experience the world around us. It guides our interactions with the environment and influences our perspectives on movement and change. Let's delve a little deeper into this concept. What exactly does it mean to have a frame of reference? A frame of reference, in simple terms, is a vantage point from which an observer examines, measures, and interprets the universe. The idea of reference frames is intrinsic to both Newtonian and Einsteinian physics, and it plays an integral role in our daily lives, though we may not always be aware of its influence. When we refer to our frame of reference, we're primarily talking about the Earth. The Earth, as we know, is perpetually in motion. It spins on its axis and orbits around the Sun. But do we feel this constant motion? No, we don't. So why is that? The reason is that everything around us, including the atmosphere and objects on Earth's surface, moves with the same speed and direction. They're all part and parcel of the same rotating system. Because we're within this system, this moving frame of reference, we don't perceive the motion. This might seem counterintuitive, but it's one of the fascinating quirks of our universe. Consider the Earth's rotation. It's a large-scale, constant motion, spinning at a speed of about 1670 km/h at the equator. Yet, it remains imperceptible to us on a daily basis. Why is that? It's because everything we observe is moving along. We don't have a stationary point of reference to contrast with the Earth's movement. This is analogous to being on a moving train. Once the train is in motion at a constant speed, you don't feel the movement. You don't sense the speed. You can walk down the aisle, pour a cup of coffee, even toss a ball in the air, and everything behaves as though the train is stationary. Unless there are external factors like acceleration or deceleration, we perceive the train and, by extension, the world as stationary. But what if you could step outside the Earth's frame of reference? What if you could observe our planet from the moon, for instance? You'd clearly see the Earth spinning, rotating on its axis once every 24 hours. It's a fascinating thought, isn't it? It's worth noting that while we don't physically feel the Earth's rotation, there are subtle. It makes its presence known. The cycle of day and night is one such example. The changing position of the stars in the night sky is another. These are gentle reminders of our planet's ceaseless motion. And yet, unless we stop and think about it, these indicators often go unnoticed. Just imagine, right now, at this very moment, you're sitting on a spinning planet, hurtling through space at an incredible speed. It's a thought that can make you feel both insignificant and profoundly connected to the universe. So, the next time you gaze up at the sky or enjoy a beautiful sunset, remember that you're riding along on a spinning planet without even feeling it. It's an amazing perspective to hold, isn't it? It asks of our place in the cosmos, of the grandeur of the universe we're a part of. And that's the magic of understanding our frame of reference. Join us next time for more fascinating insights with Wow Info. We're always here to help you perceive the world around you in new and exciting ways. Voiceover. Perception is a tricky thing, especially when it comes to motion. As we've discussed, our perception of motion is heavily influenced by our frame of reference. But what if that frame of reference is in constant motion, like our planet Earth? Let's dive a little deeper into this. Picture yourself standing in an open field, staring at the sky. To your perception, you're standing still and the world around you is motionless. But are you really? The truth is, you're not. You, me, the field, the sky, we're all spinning along with the Earth at about 1670 kilometers/hour if you're at the equator. But we don't feel this motion. We don't sense the speed. Why is that? This is because our perception of motion is relative. We perceive motion only when there's a change in speed or direction, in other words, acceleration or deceleration. But Earth's rotation is a constant motion. It doesn't accelerate or decelerate noticeably. As a result, everything around us seems stationary, even though it's moving. It's much like being on a smoothly moving train. Once the train reaches a constant speed, you don't feel the motion. You can walk down the aisle, pour yourself a cup of coffee, or even toss a ball in the air, and everything behaves as though the train is stationary. So even though we're spinning along with Earth, our perception tells us we're standing still. It's a fascinating illusion, isn't it? But remember, it's just that, an illusion. In reality, we're all part of a cosmic dance, spinning through space on this beautiful blue planet. And that's the magic of understanding our frame of reference. As we move on to our next topic, keep this in mind. Perception may paint a picture, but reality often tells a different story. Voiceover. That's it for today's cosmic journey, folks. We've spun through the mysteries of our rotating planet and the illusions it creates. Now, it's time for you to join the dance. If you found this video informative and exciting, do hit the like button. It helps us bring more such fascinating content to you. Have any thoughts or questions about our cosmic dance? We'd love to hear them. Leave us a comment below. Sharing is caring, so don't keep this cosmic journey to yourself. Share this video with your friends and family. Let them too be a part of this fascinating exploration of our universe. And if you haven't already, do subscribe to our Wow Info YouTube channel. We have many more exciting journeys ahead, and we'd love for you to join us. Thank you for being a part of this journey. Remember, the universe is vast and there's always something new to learn. So stay curious, stay informed, and we'll see you in the next